started. Okay. So on this particular one, I've got 6x to the fourth plus 41x to the third plus 42x squared minus 96x plus 6 equals negative 26. Okay. So if I'm going to solve this, what's the first thing I need to do? Add 26. So I'm just going to go ahead and erase this so I don't have to move the whole thing over again and, you know, rewrite the whole stinking thing. I'm just going to go 32. Okay. Okay. So now we've got this onslaught of different options as far as possible rational roots. This one has a ton. This one has probably too many for you to list, like I say, on a quiz or something, but I do want to go over how you would do that again. So my factors of 32 go 1 and 32, 2 and 16, 4 and 8, and that's it? Oh, that's not so bad. So then here I got 1 and 6, 2 and 3, but there's going to be, like I said, a ton, a boatload of possibilities. So if I would write them all, it's going to be 1, 2, 4, 8, 16, and 32, plus or minus all those. And then all those, 1 half, 2 halves, 4 halves, 8 halves, 16 halves, and 32 halves. But some of those have been listed already before, haven't they? Like what can I cross out? 2 over 2, 4 over 2, basically all of these, right? So that's only one new possibility, okay? And I am hoping and praying that one of those works so I don't have to do fractions all the time, but that's all right. Sometimes we got to deal with that, okay? And then your other options, I'm not going to take the time to list them all, but it'd be 4 over 1, or I'm sorry, it'd be all of these over 3, all of these over 6. Okay? So there's a ton of them. Just remember, they have to be of the form C over L. C stands for constant. What of my constant? Just not the constant, but what of my constant? Factors of my constant. Okay? Any possible rational root theorem says they have to be of the form C over L. Well, C is a factor of my constant, and L is a... What about my leading coefficient? Factor of my leading coefficient, okay? So I'm just going to take this and I'm going to say, well, using some of the special magic powers that I have, I'm going to say that I think negative 4 works, okay? So 6, negative 24, 17, oh, jeepers, these numbers are going to get big real quick. Negative 68, I got 26, negative 26 times 4 gives me 104, and then I get 8, and I get negative 32. Oh, yeah. Good deal. Okay. So this one, what I've got is I got x plus 4 is a possibility. Or no, not as a possibility. It is an actual factor. Okay. So now I'm just going to, now my list, if I wanted to, I could go back up to my list and say 32 is no longer an option, 16 is no longer an option. So we can pare the options down from looking at my, what kind of equation is this again? What do we call it? It's a depressed equation. Okay. I'm going to try negative 4 again. What the heck? Wow. How did I know? Yeah, because I got the answers right here. Yeah. So on these, it's definitely trial and error, trial and error, trial and error, trial and error. There are some, I will be honest with you, there are some theorems, like Descartes' rule of signs and the upper bound and limit bound, upper and lower limits, that we could narrow this down. But I don't think these the rules of doing this are quite as important as they used to be, because one thing. Calculator. Yeah, because we could graph it, And then from the graph, we could narrow down our options, okay? Like if I would graph this one, you know what? Since negative 4 is a double root, how would it behave at negative 4? It would bounce, okay? So a graph is always something we can use to kind of give us a little hint. And number 61 that I'm going to assign today is going to reinforce that. Okay? Oh, crap. I forgot. I've got to order a wig. I got to dress like a student. I'm going to go for your hair, dude. Yeah, there you go. Okay? Okay.
I would go for Sam's hair personally.
There you go. Okay. So then from there, we're going to factor this. I got 6x squared plus 7x plus 2. Dink, 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 dink. 2 and 3. So I got 2x, 3x, minus 2, minus 1. There we go. I think so. I think that's right. Yep, 7. And double check it here. It is correct. X plus 4, 2. Did you notice that they said their solutions were 1/2, negative, or 2/3, and negative 4 with multiplicity 2? Multiplicity 2 means that answer actually happens twice. And that's what impacts how it behaves at that point on my graph.
So how did you get the 2x minus 1, x minus 2?
Just factoring this.
Oh.
Yep. So I just took this equation that's been depressed twice, and then go from there. Okay. Okay.
New information day?
Yeah, we're gonna have some new information today, but it's mostly what I was hoping to get through yesterday. Are you done with that then? Okay, let's go. So what we've been doing is, this is section 2.4. What we've been doing is we've been breaking down equations. Today we're going to do the other way, where I'm going to give you the zeros and we're just going to build up equations. Okay? It's going to be a lot easier, but there is a little bump in the road. Okay? So let's say, for example, if I want something that has zeros of x equals negative 2, 3/2, and 1, could you guys write an equation?
Yes.
What do I do?
F of x equals a.
X plus 2. Okay, good. What else? 2x minus 3 and x minus 1. And yeah, there could be any old a we want here. And in this case, I'm not shooting for a specific point. So I'm just going to say that, and then we could multiply that out. Okay? And that is something that, we're going to, let's practice multiplying this out. So I'm going to go ahead and go 2x squared minus, this is the same factor. Oh, no, it's not. It's a little bit different. Minus 5x plus 3. I don't know. Can you guys do this next step in your head or not?
Yeah. Oh, 100%.
Okay, so 2x to the third minus x squared minus 7x plus 6. Okay. Yeah, because, and where did I get this from? Yeah, I usually probably write it out, but I'm just trying to save some time. We got 4x squared, and a negative 5x squared gives me a negative 1x squared. And here we have a 10x, negative 10x, and a 3x gives me 7x, negative 7x. Okay, so that is an equation that has those three roots. Is it the only one that has those three roots? It's actually not, because if we look at this, I've got 1 there, 1 there, 1 there. So it goes like this. But how could I have another one? Well, we don't know anything about the height. So we could have another one that goes like this. Right? So there's infinitely many. So the only thing that we just have one of them. I could multiply by 2 and it'd be steeper. I could go 1/2 and it'd be flatter, but that's just one of them. Okay? So that I don't think is too bad. But here's the big hurdle today, and I want to see how you guys handle this. I want zeros of x equals plus or minus 2 and x equals I. I want both those to be roots. I'll tell you what. I'm impressed with what I just heard. X minus I and x plus I. Have you seen that before, or was that a gut instinct, my friend? Seriously? You saw it on TikTok? Is there really good stuff on TikTok, or is it just a total waste?
There's a whole section you can click it by accident.
Oh, really? I didn't realize that. Okay. Okay, so here's the deal. He is exactly right. Now, if we think about this, let's think about a situation where we've had imaginary results. Okay? Let's say if I've used quadratic formula and I had something like, I got an answer of 3 plus or minus I over 2, right? That's an answer we'd get from quadratic formula, right? Okay. And then even if I did something like this, if I did it by completing the square, x minus 4 squared is equal to the square root of negative 20. Well, that would be x equals 4 plus or minus 2i squared. It's a 5. I just broke down square root of 20. Okay. What do you notice about both those answers? They both have a what? I. Oh, that's true, but what else do they have? They have a plus and minus. Okay. Because all imaginary answers happen in conjugate pairs. They always happen in conjugate pairs. So if a plus bi is a root, then what? A minus bi is a root. They always come in pairs. Okay? They always come in pairs. So like in this particular case, what he said was x minus I and x plus I. Well, this one we have x minus 2 and x plus 2 because there's my binomial for 2. There's my binomial for negative 2. And then this I, it can't just be I. It's got to be a plus or minus I. So x minus I and x plus I. So there are the 4 things I'm going to multiply together to give me my quartic equation that has those particular roots. Okay? Just like here, x minus 2 and x plus 2. Those are my binomials, hence x squared minus 4 times, if I multiply these two together, what do I get? X squared, what? Plus 1. Why plus 1, sir? And negative 1. So it would be plus 1 because it's minus I squared. Okay? And then we'd have this. So when we get x to the 4th minus 3x squared minus 4, there's my equation that has those roots. Okay? There's another way to skin this cat. Meow. Okay? You'll get it figured out. Picture this. Let's go backwards. Let's say, hypothetically, I've got an answer that's x is equal to plus minus I. What was my previous step? X squared equals... What did I square root to get plus or minus I? Negative 1, right? Would you guys agree with that? If I square root both sides, I get plus or minus I? I'm going backwards. I'm building this equation back up. So if I wanted to, well, if I get this set equals 0, going backwards, look at that, look at that, look at that. There's my equation that yields those two solutions. Okay? Okay. So let's do another one. This one's going to be harder. This one's going to be harder.
You said it gets harder, not easier?
Yeah. Just like life. Life gets harder, not easier.
I don't think so.
I'm just gonna stay in my mom to base me out for the rest of my life. Mom,
Shut up.
Okay. So those are my solutions. Are those my only solutions? What else comes with it? 4 minus I. And I could write that as both those options. Or I could say x is 4 plus or minus I. Okay? I'm going to do the slow way first. Okay? First binomial, x minus 3. Next binomial, x minus 4 plus I. X plus 4 plus I. And then we have to multiply all that out. Okay? But if we do it right, it's not that bad. Let's leave this x minus 3 alone. Where's my colored pens? Let's not distribute any negatives. Let's just multiply these things together. First term, x squared. Next term will be plus x times this, right? What's the next term? Minus x times that. So what's going to happen? They'll cancel each other out. So all I've got to do is I will have minus 4 plus I squared. No, it's not 16. Because I got to take it times itself. Blah, 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 blah. Okay. Something doesn't feel right at all. Hold on. Oh. No, I'm sorry. You're right. One should be plus, one should be minus. I wrote it wrong. Sorry. I'm not focusing on what I'm doing. I'm kind of sitting here focusing on the fact that nobody's taking notes, but it's totally good. Good for you. Good. You know, there is a balance there. There's no doubt about it. Because especially when you're dealing with conceptual things, there's something to be said for just going, okay, what the hell's going on here? What's he doing? How's this work? What's going? Oh, I get it. Okay. There's something to be said for that. So I totally screwed up. This is the hard way. Okay? So I got x minus my 1 root, x minus my other root. Okay, if I come up here. Okay? So it's just like it's x minus 3, x minus my root, x minus my root. That's it. Okay? Now let's do a better job multiplying these things together. X squared minus x times that minus x times this. But those are different things, so I can't do them at once here. So minus x times 4 minus I minus x times, this kind of stinks. 4 plus I, that's why I worked to find another way. Minus 4 plus I times 4 minus I. Everybody say yuck. 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 Okay. X minus 3. Notice there will be something easier coming here. X squared minus 4x. Help me out. Come on. Plus IX. Oh, I'm sorry. Minus 4x. Yeah, I'm sorry. Not everybody's as perfect as you, Sam. I'm sorry. Minus IX. Minus. Let's go ahead and multiply this in our head. 16 minus I squared, right? Yuck. Yes, it's time for another yuck. Okay. So what do I need? I get x squared. What can happen here? Minus 8x. Now, IX is canceled out. That's what I was waiting for. Good. No.
Minus 16I squared.
Nope.
Minus I squared.
Nope.
Minus 15.
Minus 15.
Nope. Nope.
40.
Nope.
Oh, wait. Oh, wait. No, it's minus 17.
Minus 17.
Do the minus.
Okay. So here's the deal. In here, remember, what is I squared?
1.
Negative. I squared is negative 1. So minus negative 1 turns it into plus 1. So we have minus 17. So then we can multiply the rest of that garbage out, right? Okay. Do you want to see an easier way?
Yes.
Okay, I'll show you tomorrow. No, I'll show you right now.
That was yuck.
Okay. This method, honestly, this one, it's ugly, but it's the same stinking thing every time. X minus 3. Let's go back up here. X minus 3. X minus my solution. X minus my other solution. Multiply it out, and then I get that. Okay? I heard a wait.
Okay, question.
Yes, Gigi, go.
Okay, so why are you taking the minus? So, like, I understand you're timing them together, so, like, why is it a minus x?
Where?
Like
right here?
Yeah, 2 minus x's on the 4 minus I.
Oh, okay. So like, why are these minus right here?
Wait, I'm trying to.
Here's what I'm doing. Let me try and clarify. He's got a great question. And that's what I want people to do. If you're not sure what's going on, let's ask. So I've got, if I take x times this, that's where that came from.
Yep.
Now I do my inners. X times this. That's where that came from.
Okay.
Is that where your question was?
Yeah, okay, never mind.
Okay, good.
I get it now.
Good job. Good. Okay. So you ready for the other way? I've come up with this myself. I've never seen a book teach this, but I think that this makes sense. X equals 4 plus or minus I. Let's go backwards. If this was my solution, what would have been my previous step? X, no. Well, I'll tell you what. Let's do some other practice here. If I add x minus 3 squared is equal to negative 8. What would I do to both sides?
Raise the second power.
No. Square root. So I'm going to go x minus 3 equals plus or minus 2i squared is 2, right?
Yep.
Now what? Add 3, right? And I get x equals 3 plus or minus 2i squared is 2. So now I want you to think about doing this backwards. Let's build it back up to where it came from. So right now, if this is a positive 4, what must it have been on the previous step? Minus 4, right? Equals plus minus I. Now, if that's a plus or minus, it must have been the result of something squared, right?
Yeah.
What's plus or minus I the square root of? Negative 1. And I think I made a mistake, so that's going to be there, going to be there, going to be there. Okay, anyway. So now I can multiply this out. What's x minus 4 squared? Let's do this in our head.
X squared.
X squared minus 8x plus 16 equals negative 1, right? Now let's go back one more step. X squared minus 8x plus 17 equals 0. Lo and behold, look what we get. Boom.
Oh, that is so much easier. That is so much easier. I like your method. You should put it in
It's easier, but okay. This is a great example of how I like to teach. I really don't. Well, I've got this. And here we go. I don't like just a recipe. Take that minus a root, that minus a root, that minus a root, and then multiply it out. I like to think of, okay, where might this answer have come from, and start to put all these pieces together, because we worked on solving things like this before, and we've all have come up with answers like that, and we could think about walking back in time and coming up with that root, or with that equation. So let's practice this. Let's practice just that part. Just that part there. Okay? Let's say x equals negative 3 plus or minus 2i.
So what you want to do first?
I want you guys to try this on your own. Okay? I want you to see if you can go backwards. Okay? And yeah, take out your pencil and write something. That'd be great. Okay? Let's go backwards and try and come up with a quadratic for which that is my answer. Otherwise, we're going to have to go x minus the quantity negative 3 plus 2i times x minus the quantity negative 3 minus 2i, and then we're going to have to multiply all that together. That makes me kind of want to throw up in my mouth a little bit. I'm going to get the answer here, and I'm going to come around and tell you if you're right. When you got an answer, let me know. I'll come around and tell you if you're right or wrong. Perfect. Oh, your 11's wrong. Square that. Oh, I don't think it's in. Yeah, 3 and 3.
Yeah. Oh my goodness.
Oh.
You did all the hard stuff perfect.
Yeah.
Anybody else?
I think I got it.
Awesome.
Please.
Oh, you're so close.
Oh.
Square this.
Oh.
Mm-mm.
No.
Mm-mm. No, because the plus or minus, the step that gave you the next thing, plus or minus, was a squared.
So, okay. Got it. I'm always stuck on one.
Perfect. Oh, you're getting there.
Mr. Rexroad, just right. Now that's right.
I can go wherever I want. I got this microphone now, so hey, what am I?
Is that right? So would that be?
That is perfect, sir.
Did I do it?
Not that hard.
No.
Just keep them
There's
back.
one. You got it wrong, probably.
What's
Oh,
what-
crap. I need to.
We just sort of run it so that
okay?
you're being your thumbnail today. It's like 2 months.
You what?
I'll be in your thumbnail.
Oh, you want to be in my thumbnail? Okay. Well, yeah, I did. You guys want one of those, do you?
Yeah.
Okay. Okay, so here we go. Let's think about how we're going to do this. Okay. Got this negative 3. So the outermost layer on this was this negative 3. So that, what must have been the previous step? X plus 3 equals plus or minus 2i. And now you can stop and you can double check. If I would do that step, Yeah, I get this. So now that plus or minus is the next thing that got hung on that. So the previous step must have been x plus 3 squared, right? But we got to square this. What's 2i squared?
4 or negative 4.
Negative 4. Okay, now we got to ask ourselves, what's x plus 3 quantity squared? It's x squared plus 6x plus 9 equals negative 4. Move that over and you get the x squared plus 6x plus 13. That is the magic quadratic for which my two solutions are negative 3 plus or minus 2i.
I like your way a lot better than.
But the question is, does it make sense? Okay. But on the other hand, does this make sense? Yeah, but boy, on this one, there's so many different ways you can make mistakes, as I so efficiently demonstrated up here. Okay? Sometimes I do that on purpose to make it look harder than it really is. And other times I just make stupid mistakes. So that's kind of, that is the big thing for today, is to see if we can come up with equations from certain roots. That is it. That is it. Page 127, 33 through 35, and that builds 35. Yep, that's a 5. I know. Okay. And I do want you to multiply these out. Okay. 33 through 35. 55. I'm going to throw a couple word problems on here so you don't totally forget how to do those. Okay. By the way, on that word problem, you'll need the volume for a pyramid. Does anybody remember the volume for a pyramid formula? Volume equals, it's base times height. It's 1/3 base times height. Is it a volume or area? No, volume. Okay. Okay. 61. 61 you'll like. 61 you'll like, trust me. I like that one pretty well. And then page 140. 61, 65, and 73. And every time I put this little bubble around there, that is a tribute to my high school math teacher, Mrs. Butler. Yep. Mrs. Butler is her name. She was the one who kind of saved me. Oh, now when you say that, are you talking about English or math teacher?
Math.
Okay.